Good morning, everyone, and welcome to week two uh, lesson, live lesson. Whatever. This is a summary of our live lesson because the live lesson was somehow too long, about 2 hours or so. I say let me just summarize it, only me, so that to minimize the time. We covered a function in week one. I believe everybody now is familiar with function. If you are not, I mean, you did not attend our live session. So let's continue with week two. Throughout this week two, we are going to treat logarithmic differentiation of functions, calculate the nth derivative of functions, and state Leibniz theorem, apply Leibniz theorem on product of two functions. Before we start logarithmic differentiation, I would like to take us back just to refresh our memory. They said logarithmic differentiation, but what is the differentiation itself? If you don't know what is differentiation, I know it's definitely going to be somehow hard for you to catch up. So I would like to take us back a little bit so that we can see what is differentiation and some rules of differentiation that we are going to be using throughout this course. So differentiation in mathematics is basically mathematics. Differentiation refers to the process of finding derivative of a function. Actually, if you don't quite understand what is function, it is definitely going to be hard for you to understand and differentiation, because throughout differentiation you will be dealing with functions. So you have to know what is function before you can proceed with differentiation. So as I said, differentiation is the process of finding the derivative of a function, which involves determining the rate of change of function with respect to its variable. And there are some certain rules while you are when you are differentiating functions. So let's go back and see what are the rules. Throughout this week, let me say we are going to treat power rule, constant rule, product rule, chain rule, and exponential rule. These 5 rules are the basic rules that you will be using in differentiation. So let's start with a power rule. If you have a function, let's say y is equals to x power n, and you are asked to find the derivative of this function, there is a rule in calculus that said if y is equals to x power n, we are talking about this power n, then derivative of this y, that is y prime, if you see 1 up here on top, that is its derivative. You are finding the first derivative of that function is equals to a n power x power n minus 1, where this a is the coefficient of this x, n is the power, the x is the variable you are differentiating, then n power n minus 1. This is the first rule in differential calculus. Wherever you see a function with power, if you are asked to differentiate it, you have to apply this formula, ax power n minus 1. Example, let's say y is equals to x power, let's say 4. So if we look at it, this is a function with power. So if you are asked to differentiate this function, that means you have to apply power rule of calculus. The coefficient a here is 1. We don't have to see it, but we know that it is there. and 1 times any number is the same to another number. So let's say 1, let's put it 1 times the power is 4 times 4 times x. We are differentiating x. If you have a, b, c, o, any alphabet you have, you are going to put it, then power 4 minus 1. This is equals to 4x cubed. So if you are asked to differentiate this, you are going to use this power rule and find this. Similarly, if you are given, let's say you are asked to find the derivative of this function, 4x cubed, derivative y prime is going to be 3, or let me say 4a. Here 4 is the a. 4 times n, the power, times 3 times the derivative, the variable you are differentiating, times x, then power n minus 1. That is, the power is 3 minus 1, which is equals to 12x square. So this is how power rule works. If you are asked to find the derivative of any function that has power, you are going to apply this formula. Then number 2, constant rule. If y is equals to, let's say 4, without any alphabet attached, the constant rule said derivative of y is equals to 0. Finish. Derivative of any constant 1 to billion is equals to 0. Then number 3, product rule. Product rule is applied when you have a function of 2 products. Let's say 2x times 3x, or 3n sine x cos x, because everything is a function in calculus. So let's see, if y is equals to sine x 4x, so sine x is a function on itself, for x is a function, and in between them is a multiplication. So product is just a multiplication of any variable, given variable. So here, if we have 2 functions, this function y is a product of 2 functions, sine x and 4x. So product rule say that ub, that is u times b, is equals to u dv over dx plus v du over dx. That means keep u constant, differentiate v, plus keep v constant, differentiate u. Which means if you have a function, you have to first identify what is your u, what is your v. So let's look at this one. So therefore y prime is equals to, let's say, okay, we have to identify y. U is equals to sine x, and v is equals to 4x. So derivative of this function if we are going to use the formula, it says keep u constant. What is our u? Keep sin x constant, sin x, and differentiate v. V is 4x. Now 4x has a power of 1, which means we are going to use power rule. 1 times 4, since the power is, we are in 4x, it has power of 1, coefficient of 1, so it's going to be 4x power 1 minus 1. If you want to put the coefficient, you say 1, a n x n minus 1, which will result in 4, because 1 minus 1 is 0. Anything power 0 is equals to 1. So the v over dx is equals to 4 plus, keep v constant, keep 4x constant, differentiate u. Derivative of sin x is equals to cos x. This is equals to 4 sin x plus 4x cos x. The derivative of this function is equals to this, using product rule. These formulas are something that you just have to memorize. You don't have to calculate. You just have to memorize. Once you see a function, you know this is the rule I'm supposed to apply, and do it, because you can be given a function that you need to apply product rule, power rule, so, and to save time you have to memorize this. These are the basics of calculus. Then okay, we treated. Then we're going to chain rule. Now chain rule said if you have a function, say y, function inside another function. If you have a function and it contains another function inside it, that's why you are going to use chain. From the name of the rule, chain, you know, they are like together, function inside another function, composite function. That's when you are going to use a chain rule. Okay, let's say you have y is equals to 4x plus, let's say 1 power 4. Now if we look at this function, the whole of this bracket here is function. It resembles something like x power n. This function as x, this 4 as power n. However, inside the function we have 4x, which is a function itself. We have 1, which is also a function itself. So here we cannot use power rule. There is no product rule here. So how are we going to do it? That's where chain rule comes in. Chain rule said that if you have a function inside another function, it's the same thing as you find the derivative of the outer function and multiply it by the derivative of the inner function. Since we said the whole of this bracket is a function, find the derivative of this function and multiply it by the derivative of the inner function. So if you say, let's say the outer function is, let's say u is equals to 4x plus 1. sorry, 4x plus 1. Then the derivative of this function is equals to 4u 4 minus 1 using power rule. This is equals to 4u cubed. We find the derivative of the outer function. The whole of the function is outer function. Then let's say v is the inner function, which is 4x plus 1. If we apply product and power rule to this and this, v will be equals to, here will be 0, power and constant rule, 1 is a constant, 0, 4x is equals to 4 using power rule. So this means the chain rule says find the derivative of the outer function and multiply it by the derivative of the inner function. That means y prime is equals to 4u cubed times 4, which is equals to 4 times 4. 4 times 4 is 16. This gives us 16 u cubed. But what is 16? 16 is equals what is u? I mean, u is equals to 4 plus 1. Sorry, 4x. There is x here. So then 16 4x plus 1 power 3. So the derivative of this function is equal to 16 into 4x plus 1 power 3. You can, this is just a, we are just try to freshen up. You can exploit because you definitely are going to use it, so you have to be good at it. I advise you to go and try to find more about it. Then the fifth one, exponential rule. If you have y is equals to e power x, the derivative of this y prime is equals to e power x again. That's true. Derivative of exponential is equals to, exponential is derivative itself. That means it does not change. If you ask to find the derivative of e power x, e power x is equals, the derivative is still the same thing. If you have y is equals to, don't get confused. Let's say you have e power 2x. This is prod and chain rule. E power 2x, e is a function, 2x is a function. So what are you going to do? Even this one too is a chain rule, because if you said okay, differentiate e power x, let's say let's just do it so that you will not get confused. E power x, you are giving a function to e power x. E power x, derivative of e is equals to e. So we have function here, we have another function here. Let u, if u is equals to, the outer function is equals to x, and v is equals to e power u, derivative of e power u is still e power u, and derivative of 1 is derivative of x using power rule is 1. So 1 times e power u is still e power u. If you substitute your x, if you with u, you will still see that nothing changed, is still e power x. So if you are given this one, your outer function is e. Okay, identify your outer function. Your inner function, I mean, is u is equals to 2x, and your v is equals to e power u. Derivative of v, e power u, is still e power u, because derivative of e does not change, and derivative of 2x is 2. Sorry, it's 2, only 2. So the derivative of this function y prime, if you look at it, you have to, that's why I say you have to memorize this function, these rules of head, memorize it. Y prime, if you look at it, this is a constant, it does not change, and this is outer function. Derivative of 2x is equals to 2. This is equals to 2 e power 2x. I hope we are clear. If you are not, try and be joining our live class so that we can interact and explain better. Okay, now since we are done with the basic rules of calculus, let me also take us back to trigonometric identities. I believe the name sounds familiar. It rings a bell. Okay, when you are dealing with trigonometric identities, wherever you see tan x is the same thing as sin x over cos x. Also, tan square x is the same thing as tan x times tan x, right? So if tan x is sin x over cos x, tan x is equals to sin x over cos x. Tan square x, I mean, is equals to sin. If you sin, let me just do it, sin x over cos x times sin x over cos x. Sin x times sin x is equals to sin square x. Cos x times cos x is equals to cos square x. So tan square x is equal to sin square x over cos. Okay, so if you simplify tan square x, tan x times tan x is going to give you this, and if you multiply this, it's going to give you sin square x over cos square x. Similarly, 1 over sin x is equals to cosec x. 1 over sin square x is equals to cosec square x. So these are just identities. When you are simplifying functions and you come across this, is the same thing. You have to simplify it to this. When you come across sin tan x, you have to simplify it to this. You come across this, simplify it, and so and so. So these are the three basic trigonometry identities we are going to be using throughout this course. These are the three trigonometric identities we are going to be using throughout this course, I believe. And the derivative of the basic trigonometric identities that you have to just memorize. Once you see, this is it. You don't even need to calculate or check paper or whatever. If you have y is equals to, if you are given a function y is equal to sin x and you are asked to find its derivative, just know it off head. Memorize it, that derivative of sin x is equal to cos x. Derivative of cos x is equals to minus sine x. Derivative of minus sine x is equals to minus cos x, and derivative of minus cos x is equals to minus sine x. For now, just put it in your head, just put it there. In our second live session, you will see how we find this. I will try to explain this as easy as possible. So far so good. These are the basic things we have to know before we move forward. Basic trigonometric identities, derivative of basic trigonometric identities. We treat differential calculus, power rule, constant rule, product rule, chain rule, exponential rule. We see how it is. You can go and just practice, and if you have any questions or something you don't understand, then don't hesitate to reach out or post it on the group, so that those who understand better can answer you. So let's go back to where we are. Logarithmic differentiation. Okay, logarithmic differentiation is a where the handout. They say logarithmic differentiation is a specialized technique within calculus. It's a specialized technique within calculus that offers unique advantage into differentiation of certain function. Okay, now what if you are given a function that you cannot apply? If you are given function that you cannot apply, let's say you cannot apply power rule, product rule, all the rules that we treated, you cannot apply them. What can you do? That's where logarithmic differentiation comes in. It can allow you to differentiate. It offers a unique advantage to differentiate certain function. It enhances kinikon. This topic teaches us how to function and how to handle certain function using the law of logarithm, which is valuable in advanced engineering and physics. Okay, what are the type of function we can apply in logarithmic differentiation method? We can differentiate function raised to another function. What do we mean by that? If you have if you have, let's say you have y is equals to 4x power 2x, 4x power 2x. Now this is a function. You can use, if you look at this, you can use chain rule, because this is a function inside another function. You can use chain rule, but there are some settings. If you look at this resembles chain rule, but if you said your outer function is equals to v, and your outer function is equals to u, your inner function is equals to v. If you are to differentiate u power v, how are you going to do it? So there are some functions that you cannot apply product rule. That's when you can use logarithmic differentiation. Also, if you have a function of several function. To differentiate product of several function, let's say you have 2x cos x sin x. Now let me write it. If you have y is equals to 2x cos x sin x, 2x is a function, cos x is a function, sin x is also a function. You cannot apply uv formula because this is the function of product of three function 1 2 3, so you cannot apply product rule. That's when you are going to use logarithmic differentiation. So first you have to identify the function and see which methods you can apply. If it's a function that you can go ahead and use product rule, chain rule, or power rule, then go ahead. In differentiate in logarithmic way, it allows us to change product to sum. When you have log a b is equals to log a plus log b using logarithm rule, as is stated here, that this topic teaches us how to handle certain function using law of logarithm. So if you are applying this method, you are going to be using law of logarithm. Log a b is equals to log a plus log b. Log a over b is equals to log a minus log v. Log a power n is equals to n log a. So these three functions, you have to just three rules, memorize them because you are going to be using it quite. And the fourth one, if you have logarithm, if you have to differentiate log f of x, the derivative of that function is equals to, because there is log, is equals to derivative of the function itself divided by the function itself. Find the derivative of function of f of x divided by the function itself. What means that if you have y is equals to 2x, log 2x, derivative of that function is equals to 2 divided by 2x. If to say this log is not there, the derivative of this function is just 2 using power rule. But because of this log, you cannot use power rule alone. That's why the rule said that if you have a function log x and you are asked to differentiate that, this is the rule. Find the derivative of the function, divide by the function itself. I hope we are together. In case if you do not understand, please, these are very, very important. You can just drop it in the comment section, or and drop it in group. And don't forget, I'll be uploading some videos at my own convenience time. I can just do a video or solve a solution, put it here. So you have to subscribe, like, so that you can be getting notification. Maybe I may not be informing that okay, I don't upload video, this and that, but if you subscribe, you can be getting notification once I upload a video. So and also you can if you have, you can make a dy over dx subject of formula. What does this mean? If you have y is equals to log x, and you are asked to find the derivative of this function. The first step that you have to take the log of both sides. Log y is equals to, no, sorry, if you have to if you're asked to find the derivative of x power x, let's say x power x, yes. Now looking at this one, you know this is a function raised to another function. You are going to use logarithmic method. If you have to, you are definitely going to take the logarithm of both sides. Log y is equals to log x power x. Now at the along the run, you are going to differentiate, find the derivative of the y itself. And using this rule, it said that if you have the log function and you are asked to find that the derivative of that log is equal to the derivative of the function divided by the function itself. So here this log y is going to be y prime derivative of y divided by the y itself. But here from the question, you are asked to find y prime only. So logarithmic way will allow you to make y prime subject of the formula. I don't know if you understand what I'm saying. Okay, let's say finally you find here, if you are solving this, you will get x, you get is equals to x log x, right? Let's say at x log x is equals to x times log x is equals to derivative of x is 1 divided by this itself. Then sorry, if you look at this is a product rule, because x is a function, log s is a function. So later if you solve it, you are going to find, I believe is ln x plus 1 if you solve it. So y prime over y is equals to ln x plus 1, but you are asked to find y prime, not y prime over y. So what are you going to do? This over 1, you have to make y prime the subject of the formula, which will give you y prime is equals to y into ln x plus 1. So it allows us to make dy over dx subject of the formula. I hope you understand it. Oh, okay, so now let's go for Mr. Uche, if you are watching this and we made a mistake, will come across where we made the mistake. Okay, the first example says find the derivative of or differentiate the function y is equals to cos 2x e power 4x divided by tan square x. If you can remember, we said tan x is equals to what? Tan x is equals to sin x over cos x. Tan square x is equals to, is this at the same time is equals to tan x times tan x. If you are to simplify tan x alone, it will give you sin x over cos x times sin x over cos x. That will give you sin square x over cos square x. So we don't start to use this. I hope you do not forget. Okay, Okay, the first example says differentiate y is equals to okay. The first example says cos 2x e power 4x all over tan square x. If you look at this function, you can't be this. We have almost three functions here. We have a chain rule. Cos 2x is a chain rule function, composite function inside another function. E power x is a function on itself, and we have three functions here and divided by another function. So here you cannot, it is going to take you very long time before you solve this. You have to first solve this, find the derivative of this. The simplest way is just to use logarithmic method. So the first step is say we are going to take the logarithm of both sides. So therefore log y is equals to log cos 2x e power 4x all over tan square x. Okay, now this one, it resembles this law. Log a over b is equals to log a minus log b. So we are going to apply the first logarithmic formula. So therefore log y is equals to log of cos 2x e power 4x minus log tan square x, right? This is our a and this is our b. If you have log a over b is equals to log a minus log b. So however, here we have a, we have b, we have two functions, cos 2x e power x. Therefore we are still going to apply this rule. Log ab is equals to log a plus log b. That's why I say you have to just memorize all these formulas from the derivative of basic trigonometry identities, the law of logarithm, all of it, combine everything, take it. This is equals to log cos 2x plus log e power 4x minus log tan square x. I hope we are together. So now what is left for us is to start removing this log, that is start differentiating. You have to start differentiating. Now if we look at cos 2x, this is a composite function inside another function. So we have to solve this one, solve this one. Therefore if y is equals to cos 2x, the outer function is, okay, let's say u is equals to 2x, y is equals to cos u. So this is the outer function, this inner function. Let's say let me use v, sorry, let me say v is equals to cos u, and the derivative of v is equals to minus sin u, and derivative of u is equals to 2. The rule of chain rule said differentiate the outer function and multiply it by the inner function. So y prime is equals to, what is our outer function? Outer function is equals to minus sin u times our inner function, which is 2. This is equals to minus, no, we have to bring this 2 to front. This is 2 sin u, and if we replace u with our initial u, this will be equals to minus 2 sin 2x. So logarithm of cos 2x is equals to minus 2 sin 2x all over cos 2x. I hope we are together. Plus, in case if you don't know how we get this, go back and check this formula. If you had log f of x, the derivative of that log is equals to the derivative of the function divided by the function itself, according to the law of the logarithm. Okay, secondly, we have log e. Let's say y is equals to log e power 4x. If we look at this rule, it say if you have log a power n is equals to n log a, right? Therefore this is equals to 4x log e, right? And log e is equals to 1, so this means log e power 4x is equals to 4x times 1, which is equals to 4x. So log e power 4x is equals to 4x. I hope we are together. It took a very long time for me to differentiate this, so therefore we are just going to take it from the handouts. So tan square x is equals to, the derivative of tan square x is equal to 2 tan x square x is equals to 2 tan x sec square x. Because it is logarithm, that means you have to divide it by tan square x according to the law of logarithm. 2 tan x sec square x, sec square x. Okay, now in this here we said sin x over cos x is equals to tan x, and tan x is also equals to this. So here we have sine 2x, we have cos 2x. This is equals to 2 tan 2x, right, plus 4x minus. Now Mr. Uche, if you are watching this, this is where we get it wrong last time. This tan x can cancel this, right, which leaves us with 2 sec square x divided by tan x. Good. I'm coming back. I am coming. Okay, I think I tried to make a mistake. So okay, tan x is equals to sine x over cos x, if we remember. So this leaves us with 2 sine x over cos x, right, times 1 over sec square x. 1 over sec square x is equals to, no, not sec square x, I mean sec square x is equals to 1 over cos square x, right? So times 1 over cos square x, right, all over sin x over, let me just sin square x over cos square x. Tan square x is equals to cos square sin square x over cos square x. This leaves us with 2 tan 2x plus 4x. Let's simplify this. Now if we multiply here, we'll have 2 minus 2 sin x times 1 will leave us with minus 2 sin x cos x times, since this is a multiplication here, cos x times cos square x will leave us with cos cube x all over sin square x over cos square x. Hello, sir. You didn't answer it. Okay, sorry guys. So if let's simplify this. 2 sin x over cos cube x divided by sin x over cos x is the same thing as if you have to multiply it, is the same thing as cos square x over sin square x. So here this cos x will cancel this, leaving us with if you know is 2, sorry, we have minus 2 sine x all over cos x sine square x, right? Again, this sine x can enter here, so this is equal to minus 2 all over cos x sine x, abi, and we can simplify this further into minus 2 times 1 over cos x times 1 over sine x, right? This is the same thing as this, and 1 over cos x is 1 over cos x is equals to 1 over cos x is what, sec? 1 over cos is sec, 1 over sine is cosec, so it's equals to minus 2 times sec x cosec x. So the whole of this place here is equals to 2 sec x cosec x, right? But here we are still with y prime over y, since we take the log of y, so we have to make y prime the subject of the formula, and this y prime now is equals to y into tan square x plus 4x plus 4x minus 2 sec x cosec square x. Sorry, I forgot x here. No, we don't have square. Maybe 1 over sine x. We don't have square. Cosec square x, and this is equal to what is our y initially? Cos 2x e power 4x all over tan square x into tan square x into 2, but into 2 and plus 4x minus 2 this one not going to give me 2 sine x cosec x. This is the final question. Let's verify. 2 tan 2x, 2 tan 2x. Okay, yeah, got tan 2x. We have 2 here, 2 tan 2x plus 4x and 2 sec x cosec x. So this is example 1. So in the next session we will try to solve example 2. Thank you very much, guys. See you soon.